now how do you see a black hole? Why is it called a black hole?
Because you can't see it, because light can't.
So I can see you now because light is hitting your face there, bouncing off and coming into my eyes. Now this, if light hits this black hole, well, it's not getting back out. So that's why we call it black. Okay, so you can't see it.
Will you just see right through it?
Well, they have actually tried to do... so you do see something, though. Now, this is Stephen Hawking. You've heard of Stephen Hawking,
yes,
right?
I've read his book.
Yeah. A brief history of time?
What was it called? The
Brief Answers to
Brief
the...
Answers to the Big
okay. Great. Yeah, so there's this thing called Hawking radiation. So even though a black hole doesn't give off light, there are particles that come into existence, in and out of existence, around, inside and around this black hole. So it does radiate off these particles. We call this Hawking radiation. So there is something that you do see around the black hole. It is, but even when you do see it, so it's like a ring of radiation around it. But when you actually were to look at a black hole, so they've taken a picture just this year, took a picture of it. And what you're seeing is actually, so imagine that's your black hole. Now, it actually just doesn't look like a little disk. It's like a sphere, right? And there's this ring around it, like the ring of Saturn, let's say, but of radiation. But at the same time, you're actually seeing the front of the ring facing towards you, and you see the back of the ring at the same time.
How is that possible? Black holes are transparent?
No, because the light escaping from that radiation... Okay, so remember, space is warped here. So the light traveling actually bends. It's called gravitational lensing. This actually happens like around the sun or a star, something with lots of gravity, that light coming from something behind that star can actually bend around the star and still get to you. Okay, so imagine you're a star and there's something behind you there, right? Light coming off of it, if you have enough gravity, can actually bend around you and still get to me. And because this has so much gravity that you're seeing the back and the front of it at the same time.
Which makes no sense, because the light should have been sucked in.
Yeah, but then that light hadn't fallen into the event horizon.
Yet.
Yeah, but it's outside the event horizon, so it's fine. It's going to get past. It will just get bent as it goes around.
The fact that we can see that light, tells us that it did not cross the event horizon. Otherwise, it would just be the blackness.
Inside that, you're not seeing anything at all.
Now, Elyes, so if we imagine back to Herschel's trying to figure all this out, and he's come up with his theory that these black holes exist, has he just made that up, do you think? Or does he have a reason?
He had a reason, because... Oh, no, that was the dark matter explanation.
Well, actually, it's very similar to the dark matter explanation.
Because something must have been holding the other things together, the stars together, the planets together.
So we had an understanding, and we had a growing understanding of why stuff in space and stuff anywhere, but if you take space, why the solar system behaves the way it does, what impact gravity has. And what we were starting to observe was the sort of response to black holes, a bit like you've just mentioned dark matter. So dark matter we know nothing about, but scientists theorize that it must exist because we see its impact, we see its effect on everything else. So something is making stuff. So with dark matter, something is making things expand away from everything else. With black holes, something, as you rightly just said, is kind of holding all this stuff together. And the way that the stars are moving within our galaxy must mean that there is something causing that. And that is where he started theorizing, and then we started kind of hunting to prove that these black holes exist.
Yeah.
Which is cool.
Which is very cool. Yeah, so that's how they discovered the one so we haven't actually seen the black hole in the center of our galaxy. What was it called? Sagittarius.
It's one of those moments where whatever you say, I'm going to nod.
So the black hole, supermassive black hole in the center of our Milky Way galaxy. We can't actually see it. We don't see any Hawking radiation because it's just not close enough, I guess. But what we're seeing is that stars around or close to it are behaving in a way that suggests there's an incredible amount of gravity in the center there. So we're seeing the effects, and that's how we know that it's there. And judging by how they're moving, we can also know how much gravity is there. And because we know how much gravity is there, then we know how heavy that black hole is, how massive it is. That's a supermassive one.